Hello everyone, a very warm welcome to this video. In this video we are going to talk about high availability. Now data node has a protection because the replication factor is 3, but name node has no such protection, and in this video we are going to see what are the two ways where you can protect the name node. So let's get going. So there are two ways to protect name node. First is the old way or the classic way, or secondary name node way. The second way is the new way, the high availability way, or the standby name node way. So these are two ways in which you can protect the name node. In modern cluster, there is no reason why somebody would want to go for old way, but for understanding perspective, we will cover both the ways in this particular video. So let's first talk about the old way. In the old way, we had name node and we had secondary name node. We had name node and we had secondary name node. Now, name node would basically have two files. So anything that comes to name node, it's written in a file called edits file. Edits file is nothing but a file that is in RAM and not committed to the disk. And then you have an FS image file, which was basically the entire history file. So whatever is getting written right now would go to edits, and after some time this would get merged with the FS image. How that works we'll see. Now all the data that would go into edits file. So let's say it's 9 in the morning and we've just now set up a Hadoop cluster. So the size of edits would be 0 MB, and the size of FS image would also be 0 MB. Now from 9 o'clock you start writing metadata to name node, and let's say by 10 o'clock the size of edits file is now 40 MB and this is 0 MB. So this was 10. So at 10 o'clock it was 40 MB and 0 MB. At 10, secondary name node would call name node and say, please send me these two files. So this 40 MB travels there and this 0 MB travels there, and both get merged, and what you get is one FS image file which is 40 MB. So this 40 MB gets copied here as the history file, and at 10 o'clock we will start with a new edits file. Again, for 1 hour all the metadata gets written, and at 11 o'clock let's say we have 60 MB of metadata. So 60 plus 40 turns out to be 100. So they both first travel to, so here it will be 60 plus 40. So the new FS image would be 100 MB, and this is passed here, and we start with a new edits file which is 0. This operation of merging is done by secondary name node, and it's also called checkpointing. Now there are a couple of things to be aware of this. First, secondary name node is just checkpointing or is just a backup. Secondary name node can never get promoted as name node. If name node goes down, the backup from secondary name node can be used to bring up a new name node. So these are three most important points about the old way. In a nutshell, what we are talking about is if in the old way, if name node goes down, there would certainly be a downtime. There is no way to escape a downtime. Secondary name node keeps the backup of name node, but there is no way it can get promoted as name node. It is just doing the bookkeeping or the checkpointing operation. So this was old way of doing things, which was not very friendly, because if name node goes down, there would be downtime. That's why in the new way, there is no concept of secondary name node, but there is a standby where if one goes down, the other would come up. So in the next slide, what we are going to see, or the next drawing, what we are going to see is how does Hadoop work or name node work with high availability. So with high availability, what happens is if one name node goes down, other will take over. Let's get going. So the next way we are going to talk about is called as new way. In this new way, what we would have is two name nodes. So there is name node and there is standby name node. Now, we as clients will talk to the name node and write the metadata. So we will always contact the active name node. So once we hit the active name node, the name node will write its metadata. But because we want it to be a failover, that means as soon as one name node goes down, other takes over. What we really need is a shared location where metadata is written. And the shared location is typically 3 locations, and they are called as journal nodes. So here there'll be 3 journal nodes. So what happens is when name node gets a request, name node writes data to journal nodes and the other name node reads it from journal nodes. But name node itself is not capable of writing to journal nodes. So it has a service that does that, and that service is called as Quorum Journal Manager. So this is a service that's part of the name node and it's installed on both. For name node, the Quorum Journal Manager does the job of writing shared metadata or writing metadata to a shared location. And in the second case, Quorum Journal Manager is doing the job of reading this metadata. So that keeps both the name nodes in sync. What really happens is name node writes data to journal nodes and the other name node is reading it from them. For a new directory or a file that is dumped into HDFS, for it to be committed, minimum 2 journal nodes should agree or acknowledge that yes, this directory is created. So that is how the name node and standby name node thing works. But now that alone is not enough, because there could be a case of split brain situation where if one name node goes down, other takes over, and immediately in 90 seconds, first name node comes up. There could be a situation of a split brain. So what you really require is somebody who does the solution or conflict resolution or a match referee. A match referee that would always decide who's active, who's not, and will keep track of that. So in our case, or in Hadoop's case, the match referee is called as zookeeper. The match referee is called as zookeeper. So there'll be 3 zookeeper servers. The reason being, if there is a conflict, we are supposed to establish a majority. We are supposed to establish a majority. So in case a name node goes down and instantly comes up, zookeeper would have already elected a new name node and they would not let the old name node have any issues or create any issues. The software that talks to zookeeper on name node or heartbeats into zookeeper from name node is called as zookeeper failover controller, ZKFC. So zookeeper failover controller would continuously send heartbeat to the zookeeper quorum that this is active or this is standby. So based on that, zookeeper continuously knows which name node is active and which one is down. That is how high availability works. It's called zookeeper failover controller. And in our lab, we are going to see how to set up this entire high availability system manually as well as automatically using Cloudera Manager. So in this video, we saw how to protect your name node the old way and how to protect your name node the new way. And when we will see the lab, we will see how to protect your name node the new way, both in an automated and manual fashion. Thanks for watching this video.